Okay, everyone. So welcome to this live stream about our fourth session. First, I would like to do this announcement that Dr. James Tour is coming to Finding Truth. And Dr. Tour is one of the top scientists in the world and definitely one of the top 10 chemists. And I'm going to be doing an interview with him on August 21st. So I would encourage you to send any questions you have about the RNA, DNA, mutations, information, abiogenesis, etc. And I think it will be a very exciting thing to have him with us on the show. Next, I'm gonna use this episode because it was my bad that I was very late publishing session 4. It was only published actually at 12 hours ago or something, or 14 hours ago, which I am sure did not give enough time to you to ask questions. So I'm going to use this live stream to show you one paper that I referenced, for example, in this episode. And the reason is that one of the objectives of this course, as was in the trailer, is that you are able to go through papers and find out the truth for yourself, which is, I'm sure, something that many evolutionists would just tell you what you're saying is wrong, or evolution is scientifically proven, and we have the papers for it, etc. But the reality is that in so many cases, they would throw a paper at you. The paper has a specific title, and the title is not necessarily representative of the content of the paper. I'm going to show you one of those. I encourage you so much to go to the course site. And on the course site, you will find a new place called articles. And not the articles is the new, I'm sorry, literature review. And I will be putting there under each week the literature, some select literature. I will be putting papers there with comments on them. So you get used to going through the papers and looking at the comments yourself and finding out the truth yourself from the very evolutionary documentation. So let's start with this. Yeah. So this paper is called Selection of an Improved RNA Polymerase Ribozyme with Superior Extension and Fidelity. So remember in session 4, we were talking about the RNA World Hypothesis. And the RNA World Hypothesis tells you that there was once upon a time a world where RNA was doing everything. And in this world, RNA was doing the role of the genetic material, storing the genetic material, and also doing the role of enzymes, because we need enzymes for life. Without enzymes, there is very low chances for life to thrive. So you need the genetic material and you need the enzymes. And one important thing is that you need the enzymes to replicate the genetic material, like we saw, for example, with the DNA replication process, where those machines will go, they will read the material, and they would do the job. So I'm going to go now through this paper, and the paper is about this very topic, the matter of RNA being able to act as a catalyst. So the topic of the paper is selection of an improved RNA polymerase ribozyme with superior extension and fidelity. And the impression you get from the title is that, you know, there is already RNA polymerase ribozymes that are good enough, and we're looking for one that is superior in its extension abilities and in the fidelity of the copying. So the first thing we notice is that the title is very suggestive, and that unfortunately the paper will not live up to what is suggested by the title. In the session, I indicated that against what is typically said in the evolutionary journalism or the media about evolution, about RNA hypothesis, is that yes, RNA can do the job. RNA is good as an enzyme, and you can have RNA that will replicate itself. But this is not what the scientific literature says. So this paper, let's go through this, because this will be short, because again, it was my bad that I published the episode very late, and I'm sure it was very challenging for anybody to go through the big material and also to send questions. So I'm gonna leave that. It will be recorded. You can see it after you have seen session 4, and then you will know what I'm talking about. So let's see. I've already, you will find this already in the literature review section on the course page, literature review 4. Let's look at the introduction. It says here what? It says, the RNA World Hypothesis suggests that random metabolism evolved from a system, so that modern metabolism evolved from a system where RNA served the genomic role, now filled by DNA, and the catalytic role presently performed by protein. Okay, very well. We said that in the session. It goes on and it says, although RNA machines like the ribosome are believed to be relics of an RNA-based past, and I would like to note here that ribosomes are not RNA machines, as I have indicated in the course. And I don't know why such things would be said in a peer-reviewed scientific paper. A ribosome, yes, it has ribozymes, it has RNA catalysts, but it also has at least 35% proteins. So anyway, so although RNA machines like the ribosome are believed to be relics of an RNA-based past, I don't know what the word believe means here. Again, very speculative and leading the question. The current dominance of protein catalysts prevents us from learning how RNA-based life might have replicated. So this is what you find when you read the literature. You will talk to somebody who would just accept evolution as 100% truth. Okay, so yeah, there is a comment from Dapper here, says, so the peer-reviewed paper is wrong about a basic fact. Well, you can ask the authors. Yet what I see many times, Dapper, in such literature, is that you will find many interpolations, like the paper or the authors would like to fill in the spaces for the theory when they don't need even to do so. It's very strange, but it is a common observation. I find it in paper after paper, over and over again, and I find it very annoying when I am discussing or debating with somebody who would then throw at me a paper and points me to the title or to the abstract. But when you go to the paper itself, to the real content of the paper, you don't find that the title or sometimes the abstract and sometimes the conclusion are not very consistent with the meat of the paper. And in many cases, the paper is innocent, and scientific journalism or some science explainers would hype things up in an unacceptable way. And I think that this is it happens all the time, unfortunately. Dapper also says, is it not possible that instead you, as someone not in this field, might not understand what they're saying? Well, that's why I decided to do this. Probably in every weekly live stream, I will pick one of the papers that are relevant to the session, and we will go. So I don't think we will have disagreement when we read a statement like this. Although RNA machines like the ribosome are believed to be so and so, RNA machines like the ribosome. Why he is not saying RNA/protein machines? Isn't this more appropriate to say in a scientific paper? Anyway, let's continue. This is not the main point I'm looking at here, because after that he goes more honest, and he says the current dominance of protein catalysts prevents us from learning how RNA-based life might have replicated. And again, one of the things I find in evolutionary literature is that contradictions are even in the same very paper. So the first part, it says that this is a relic from the past, and the second part saying that the dominance of protein catalysts prevent us from learning how RNA-based life might have replicated. So if proteins are obscuring it and making you not learn about it, why are you asserting or believing that they are relics of RNA-based world? Isn't this a kind of contradiction that is not at least not appropriate to find in a scientific paper where anything that you believe does not make a difference, but what you can prove is what makes a difference? So again, anyway, it goes. Nevertheless, one can imagine. Okay, very nice in a scientific literature too. One can imagine constructing a minimal autoreplicative system using RNA catalysis. Okay, you can imagine. Let's see if the paper can support this imagination. Yeah, so Dapper again says, let me show you what Dapper is saying again here. So he's giving an excuse to the author, and he's saying, because we've known ribozymes have protein for decades, but the fact that they surround RNA is a relatively new discovery. Therefore, RNA machine. No, this paper is not, it is not a high school simplification. This is a scientific paper talking about an important subject and in a specialized journal. So making these mistakes, in my opinion, are not appropriate. Anyway, so it says one can imagine constructing a minimal autoreplicative system using RNA catalysis. Okay. But you can imagine. Let's see if his own work makes this imagination relative, makes this imagination probable or not. It's confined within small model compartments, in analogy to a modern cell. Okay. I would like also to point you to this one that I am putting here in. So I will. If you go to the literature review, you'll find me having the, and you open this with Acrobat. This is important because you can see then at the right all the comments, and you can see also those small ones I'm putting here in the comment speculation as usual with the theory. If you click on the red one, you will find it shows you my comment here on the right. He says, arguably, the greatest limitation of the RNA world hypothesis is the lack of an RNA replicase ribozyme, which has been coined the holy grail in the ribozyme community. And the funny thing, I have been after the last episode, session 3, where I talked about Luca and the 7 paradoxes about Luca, and I said that there is no known RNA catalyst that can replicate RNA, and I was having this discussion on a scientific forum, and people saying, hey, haven't you heard about ribozymes? So guys, please first look into the literature. So the author says, arguably, the greatest limitation of the RNA world hypothesis is the lack of an RNA replicase ribozyme. I pointed this out clearly in the session, and I'm sure I'm going to have the same comment again, regardless, I am putting things in the comments and put heavy references all over the place, and I write an article that takes really this exercise almost every 1 minute in the session almost costs 1 hour or more of writing, arranging material, etc. So this is very important. It is something that I mentioned very clearly in the episode, and this immediately kills the whole RNA hypothesis. It's dead in its tracks. The RNA World Hypothesis says you only need RNA to have everything, while it is known already very well that there is an absence of a ribosome. A ribosome is a ribonucleic enzyme. That means an enzyme that is made of RNA. So there is no RNA replicase ribosome. You can only have an RNA replicase that has its constitution of proteins, which is what we have referred to in the session. It's called RNA-dependent RNA replicase, or RNA replicase for short, RNA-dependent RNA polymerase, sorry, or RNA replicase for short, and it is made of proteins. And then we go and forward. Here he goes and says this. He says, this polymerase, he's talking about his work. You can read the one in the middle, and we can read the middle because we'll just cover this paper and close. It says, guided by the catalytic mechanisms utilized by protein polymerases, attempts have focused on isolating ribozymes that are capable of polymerizing a primer in a template-dependent manner as a key first step in the creation of a replicase ribosome. Okay, so now what this paper is about is that we are here artificially trying to create in the lab a ribosome, and how it's being led is by mimicking how how the protein polymerases work in light of what we see in nature already. So, okay, fine, it's good that we do the research, but the more important is to be honest about what the research says, and not to write papers and not to do media shows that are not consistent with what the science actually says. He goes on, no approach has been more successful than the efforts that resulted in the 189 nucleotide long round 18 polymerase, which was selected from a pool built by appending a 76-stranded nucleotide accessory sequence to the class 1 ligase, and he references a paper. Okay, this is, wow, this is the success. 189 nucleotides. So the average virus genome is 9 kilobases. The maximum is 29 kilobases. And we're hailing the success of 189. And this is not yet everything. Let's see what's really there. It says this polymerase can extend an RNA primer template complex by up to 14 nucleotides in a template-directed manner after 24 hours of incubation. This is the best that we can do, and there is still something called the RNA hypothesis put on the table. This is the best. You put you put our best achievement, ribosome. It extends the 189 nucleotide long material up to, not even, he's sure he's gonna do it to 14 every time, up to 14 nucleotides, and this happens over 24 hours. This is like a joke. So nonetheless, the ability of the round 18 ribosome to polymerize more than one RNA helical turn is limited. More typically, the round 18 polymerase adds only a few nucleotides to a given template complex. This poor polymerization ability has been attributed to weak and highly variable template recognition. Hooray. So he starts by saying, hooray, hooray, we have 189, we have a great achievement. It turns out to be 189 NT long. And then it goes up to 14 nucleotides. and then it doesn't do it every time. It just does few, and this is because of its very poor ability of recognition. Wow. And there is still, up till this day, an RNA hypothesis sitting on the table. No empirical evidence of its possibility whatsoever. Nonetheless, I have been very charitable with this hypothesis in the session, and I said, okay, even if, let's see if we can assume that there is replicase. And then it doesn't work, because you need to read the replicase via ribosome, and the ribosome has proteins. And they say, okay, let's assume we have the ribosomes. But eventually you hit the paradoxes, because to code for the replicase and to code for the ribosomes and for all the enzymes that need to work around them, etc., you need a huge genome. And then the material for the genetic material for the metabolism and genetic material to code for the membrane, etc. And this is, if you need a minimal cell, you need 580 kilobases. And this thing cannot even do 18 bases or 14 in a good manner. Okay, let's see what he says here. So, which in turn is related in a complex fashion to the fidelity of the enzyme. So the enzyme does not have fidelity, and it does not have good recognition. Okay. So, and then he says, although the fidelity is high, if the polymerase successfully extends a primer by as much as 11 nucleotides. By the way, I'm not blaming him that this is what nature can do. RNA is not there to do the role of DNA. RNA has another role. RNA to a cell is like memory to a computer. DNA to a cell is like a hard disk to a computer. Viruses use RNA because they are more or less like messages. They are not intended to be, so you have RNA viruses that have short messages, they already use RNA, and when the virus is complex, it uses DNA. And we have seen in session 4, I've given an example for viruses like the Mimi virus and other large genome viruses, which are DNA viruses. So when it's big, already nature uses DNA. It's okay that there is research and there is ambition trying to find something out. Maybe we can find a good practical use for this in medicine or for whatever. But to the extent that the cutting edge of scientific research says that this is not possible, and to our best effort, it is miserably a failure to replicate RNA using autocatalysis. And it is really a joke to keep insisting that there is an RNA world where RNA does everything. He goes on, although, so yeah, we've gone through this. So 11 nucleotides, okay? This measurement does not take into account, it goes more hilarious now, okay? So it can successfully extend to 11 nucleotides, but this measurement does not take into account aborted extension products that terminate due to a misincorporation of a nucleotide. So let's look at this picture. You can reach 11, but we will not count the ones that fail in the middle. What is this? So this is where I put a comment that the results are catastrophic. You can really now go on reading the rest of the paper, and here he would show how this is working and etc. But I have later another comment that I would like. It's fun reading these papers, and it's hilarious also, not only fun, to see what the real literature says and what the media says. It's depressing sometimes. All right, so yeah, so he goes on, and he says, all modern protein DNA polymerases, in addition to being complex multi-subunit machineries, depend on other enhancing factors to reach their full processive potential. And I'm putting a comment here that the difference is really obvious why life is based on DNA, not RNA. We have an integrated system that has DNA with RNA, with proteins, working in harmony to deliver something. And we have analogies with this to the machines that we develop, like computers. And you will not get a properly functioning computer that does not have permanent storage, that does not have a hard disk like the DNA, that has only RAM. And when the power goes down, it decays immediately. RNA is very analogous to RAM, volatile memory. It is not there to sit around for the lifetime of an organism. It is there to be a result transcription of DNA, produce the protein, and then get decomposed, and the nucleotides will be recycled. And here's a final one I'm doing here. For instance, he goes on. He says, after going through his analysis, for instance, the core DNA polymerase 3 of Escherichia coli polymerizes DNA with a rate. Let's this is fun. Let's see the comparison between the efficiency and magnificence of the DNA system, because this is what it's supposed to do, versus the RNA. The core DNA polymerase 3 of Escherichia coli polymerizes DNA with a rate of 20 nucleotides per second. 20 nucleotides per second. Okay? Remember the other guy? He was going 14 nucleotides, keeping his praying all night for 24 hours for it to fail most of the time. It will not reach the final thing. It will be happy to reach 11, and he will have to count out the ones that terminated in the middle. And DNA polymerase will do 20 nucleotides per second, and a processivity only of tens of nucleotides. By interacting with the beta-clamp protein, its rate of polymerization is improved by a factor of 40. You remember he was talking about that proteins like cofactors play a role, and the system goes, ballistic. And when you have this beta-clamp protein, the processing goes to 50,000 nucleotides per second. Wow. And he says B661 has a respectable polymerization. This is the B661 is his superior RNA ribozyme that he is selecting for in this research. So it has a respectful polymerization rate with incorporation rates reaching what? 0.6 nucleotide per minute. It's very respectable. It's respectable in terms of RNA not being built to do that. It is nothing compared to the polymerase machinery of DNA, the protein ones, with their protein helpers. Still far less than 100 minute to the -1. Observes for phosphodiester bond formation by class 1 ligase core. And I think this is enough for the paper. Why I wanted to do this with you today? This is a paper published in the RNA Society. So back to your comment, Dapper, this is not a guy who does not know what RNA is talking about. This is a very specialized journal. And it's fun and it's nice that people are looking for solutions and doing things with RNA, because RNA is quite important. And if we can do things, maybe we treat diseases, maybe we help people. But to say that the RNA hypothesis is a widely accepted thing with this status quo of research is really very disappointing. I wanted to set this up today, so we will do a similar thing in the following episodes. And I would encourage everyone to start looking into the literature review section, starting this episode and the following ones. Because one of the objectives of this course is that I don't want you only to know if evolution is true or false. I want you to be able to verify what I'm saying yourself, and being able to read the material written by evolutionary biologists and look at the real status quo in the scientific community. So yeah, Dapper says again, the specialized journal doesn't agree with you, a non-specialist, about the plausibility of a hypothesis. I don't care if it agrees or not. I care about the facts that are in the paper, and in every paper. So I open a paper, I don't care about the poetic title that the writer has put there. I question every line versus the other paper versus the facts that I already know from other papers that are facts. So when somebody says RNA ribosomes and just accidentally forgets to mention proteins, I compare that to the facts that I know. And then I look into the new facts that are brought forward by this paper, and I compare it to what is popularized in the media about the theory and about the hypotheses of the theory and the explanations of the theory and the extrapolations of the theory. And as this writer said, about the imaginations of the theory and the assumptions of the theory. And they boil down exactly to this, exactly to what he has mentioned. One can imagine, one can. So it's just a matter of, as he writes, one can imagine constructing a minimal autoreplicative system using RNA catalysts. Okay, you can imagine, but it stays there. I'm just giving you this as one example, guys. When you watch this, after you watch session 4, and every paper I am reading, there are significant odds that I find more or less the same thing in every significant paper that I read, every single one. I don't want to mention a percentage so as not to be unfair, because sometimes I have not read every single paper in the universe, you know. Okay, so yeah. Finally, I would like to remind you guys, when you have seen this, that I'm going to be doing this interview with Dr. James Storr, the renowned scientist, synthetic chemist, expert with nanotechnology, and even with computer science, which he teaches. So very close to the topics that I would like to talk about. It's coming on the 21st. So if you're a course participant or a channel registered member, please do send your questions, and I will try as much as time permitting to post your questions to him. Thank you, guys. And those who have not had the opportunity to read the material and watch session 4 in due time, pardon me for posting it late, but please do feel free to post your questions about session 4 within this week, and I will answer both the session 4 and the session 5 questions together next Saturday. And watch out for our next session, which will be about proteins. Very interesting subject, and one with great paradoxes too. And Assalamu alaikum wa rahmatullah. Peace be upon you all, and see you again soon.